Okay, so today I'm going to talk about OpenGL programs. So first let's add our OpenGL machine again. So there's a process at the bottom with vertex shader, keeping rasterizing, and fragment shader, and there's a whole bunch of programs, and there's one that is currently selected. So what are these things? So basically this is a program. It includes code for the vertex shader, it includes codes for the fragment shader, it has locations for uniforms, it also has uniform values, and it has location for attributes. Okay, now let's look at this program in more detail. So, it includes code for the vertex shader. Here's an example of a very simple vertex shader that just takes a vertex and return it as its final position. So the object is not moved, whatever is the input is just stay the same. So the input of the vertex shader is what we call an attribute. So every vertices has attributes. The vertices here only have their location. That's the only information I have for this program. And in the program, that argument has the name vPosition. But in OpenGL, it doesn't. In OpenGL, it has a location number, which in this case could be location number 1. Now, a very important part of the vertex shader is to return the final position of the vertex. Now, if you want to know the location number for an attribute, you can use the following code at the bottom, which is gl get attribute location, the program number, whatever ID OpenGL returns you when you created the program, and the name of the argument as a string. And that will return you the location of the program. You can see init shader file, initShader.cpp file from Angel's textbooks, which we're using. You can also see that in there you can fix the location, so you can decide that vPosition is always location 1 instead of letting the linker decide. Okay, so similarly to vertex shader, fragment shader also have some piece of code. Here's an example of a very simple fragment shader. It's just receiving a color and it's setting it as the final color. It receives a uniform, and the uniform-like attributes have specific locations, so they're not text from OpenGL point of view, they are just numbers. So that's very similar to attributes. And then the important output variable which you want is what will be the color of that fragment. Now, similarly with attributes, you can get the location of a uniform number using the following piece of code, just get uniform location and your program number and the name of the uniform as a string. But if you want to set the value of a program uniform, it's a little bit more complicated. The very first thing you need to do is actually make the program the current program. Otherwise, you won't be able to access its uniform. You're always accessing the uniforms of the selected program. So you use GLUseProgram to select your program. Once the program is selected, you can actually call one of the GLUniform function to set the value of that uniform. And there you go. That uniform is ready. Now, this is not everything. You can see that little arrow between the vertex and the fragment shader. And this is about variables that can pass from one to the other one. So here's an example of a slightly more complex vertex shader. It has two input variables, so two attributes, position and text coordinate. And it also has an output variable, vVartex code. vVartex code is actually smoothed out, meaning that every fragment will have an interpolated value based on the vertex at each corner of the line or of the triangle that it's generating. And GL position is output as usual. So this is the variable of interest. We're generating a new variable and we want it to be interpolated. This is what smooth means. So every fragment will have its own texture coordinates, basically, in this case. Now, the fragment also has a piece of code, and in this case, it has a uniform, which you can see in red. And most importantly, is that it has a matching input variable with the exact same name as the output variable and basically the same declaration, except that it's an int variable. So now it can be used in the fragment shader, so the fragment shader will receive that information. for every fragment. Okay, so to wrap up, basically you have all your programs that are in OpenGL that you may have loaded, compiled, and linked. And one of them is the current program. Whichever it is doesn't really matter. But whenever you want to draw something, there's a couple of steps you need to do. The first one is select the current program, calling GLU's program. The second one is update your uniforms if you need to. And then you can choose the objects you want to draw, set the texture, some other things we'll see in some other presentation. And finally, you call on the draw arrays that will basically run your program through the whole process. That's it.